Hello everyone and welcome to the second part of my Web LLM attack video series. In this video, I'm going to solve the second lab of Web LLM attack learning path by PortSwigger. And this lab is about chaining vulnerabilities in LLM APIs. This vulnerability occurs when the output of LLM is directly used as the input to call some critical functions such as APIs, SQL queries, or system level commands. And when the user input can influence the output of LLM, there could be the possibility that the attacker crafts some prompts and manipulate LLM into creating some harmful commands. With these explanations, let's jump into the lab. As explained here, this lab contains an OS command injection vulnerability that can be exploited via its APIs. And we can call these APIs using LLM. To solve the lab, we have to delete the moral.txt file from Carlos' home directory. Let's access the lab. As you see, it simulates an online shop with a list of products and similar buttons and links to the previous lab. And here's also this live chat where we can directly talk to LLM. And if you remember, there are three steps for analyzing LLM vulnerability, and the first one was to identify LLM's input. And by now we have identified the LLM's direct input, which was this chatbot. Now we can go further and find out the data and APIs available to LLM. And we can do this simply by asking what APIs does it have. And it replies that there are three APIs available. The first one is password reset, which takes the username or email address of the user as the input. The next one is subscribe to newsletter that receives the email address of the user. And the last one is product info that requires product name or identity of the product as the input arguments. And now we can go to the last step to analyze this attack surface and detect possible vulnerabilities. We can start from the first API, that is password reset, and let's ask LLM to reset the password of Carlos. And it says that the password reset email has been successfully sent to Carlos. We have access to our inbox. Of course, we are not Carlos, but let's see if we receive something. No, our address is something different and the inbox is empty. Uh, but something that's clear here is that based on our provided username, there should be some queries, maybe some SQL queries to find the relevant email address of this user. So here, SQL injection vulnerability could also be possible based on the LLM's output. There could be some SQL query created, and someone maybe can inject some SQL commands into the username. But here we know that the problem is OS command injection, and our focus is on OS command injection. Okay, let's try to use our email address to see what happens when we use an email address to ask for resetting the password. Reset the password of the user with this email address. And it complains that it could not find the user with this email address. Let's check our inbox and it's empty. This is odd because our provided email address is actually true. Uh, so let's try again with a wrong address just by adding some random string at the end of this email address. Let's repeat our request. And again, it says that it could not find the user with the provided email address. So maybe this API is not completely implemented, and we can go to the second API, subscribe to the newsletter, and ask LLM to actually subscribe the user with this email address and see what happens. And it says that the user with this email address has been successfully subscribed. Let's check our inbox. Yes, we have received an email to our own address with this subject, welcome to our newsletter, and from Web Security Academy. And the body is thank you for subscribing to our newsletter. Let's view the raw data. You see the fields here, all the fields except for the timestamp and the destination email, which is our own email address, are constant fields.
Let's talk about the vulnerability. It could be the case that this email has been sent by executing a mail service using a system call. And this mail service has some input arguments that could be extracted from the LLM output. And among these input arguments is user email address, which is received directly from user input. So we have the complete scenario. We have some user input that influences LLM output and is used to make a critical function call. So we might be able to inject some OS commands into the email address and hope that these commands are also executed in the system call. And you know that there are some symbols used to inject OS commands into the input data. Let's go back to the lab, to the chatbot. Now we repeat the previous request and try to inject some OS command to the email address. For example, we can inject ls using semicolon at the end of the email address, and it says that it has successfully sent an email to this address that contains the injected string at the end. We can check our inbox and we see that we have not received anything because the address is something different from our address. Let's inject to the beginning and see what it performs. This time it complains that this address does not exist. So maybe it processes the beginning and end of the input differently, but something that we are sure is that the injected string is considered part of the email address. So the input argument could be escaped or could be used in code.
Therefore, the injected command is not executed because it is considered as part of the email address argument of the mail instruction. We know that there are different symbols that we can use to inject OS commands. And among these symbols, there are two that have more chance to let the injected command be executed even if it is quoted. These symbols are question mark and backtick. In our scenario, for example, if we use question mark to inject a ls command, we are telling the system to execute first the ls command and then replace it with the result, and then execute the whole mail instruction. Of course, we have corrupted the email address argument and we will receive some error messages, but maybe we have some chance to see the result of ls command in the error messages or logs of the system. Let's try this. I repeat the previous request and this time I inject the ls command using the question mark. And we can do this anywhere in the email address, for example, after the attacker word, because we know that finally we are corrupting the email address. Let's send the request. And it says that the user with this email address has been successfully subscribed. And interestingly, the email address contains the injected command, not the result of its execution. Let's check the inbox. We have received a new email, and in the destination email, we can see the result of ls command. That is moral.txt file, which is the file we are looking for. And it's somehow strange because our email address is something different, and we should not have received this email. But I guess it's just for educational purposes to show us the result of the injected command execution. We can repeat this and use the backtick symbol to show that both of them can work here. And again, we have subscribed this email address and we have received another email with the result of this command. And now we can go further and remove this file to solve the lab. Remove moral txt. Yes, we have solved the lab. It was better if we checked the current directory to make sure that that was the file that we were looking for in Carlos' home directory, but since we have solved the lab, it shows that this was the intended file. To defend against this attack, avoid using shell or command line unless it is absolutely necessary. For example, when we want to send an email, we can use high-level libraries instead of invoking the shell directly. But if we really have to execute some external commands, use argument-safe execution. For example, in Python, we can use subprocess run and turn off the shell option. By doing so, Python skips the shell and directly executes the binary. There would be no shell parsing, so special characters have no effect and they are treated just as literal arguments. Do not execute LLM output directly, because the generated output could be unpredictable and even harmful when it is not strictly validated. If you really have to use LLM generated strings as part of commands, you should sanitize them carefully. Remove special characters and validate them against well known and safe formats. Just accept known safe values and carefully validate or parse any external input. And execute the process and application with the minimum set of permissions required. Do not run the process as root or with administrative privileges unless it is absolutely necessary. This helps you to reduce the potential damage of a successful attack. And finally, log LLM interactions. Record everything like prompts, output, and usage patterns. Logs help to detect abuses, investigate incidents, and improve the safety mechanisms over time. That's it for this video. Thank you for watching.